Okay. We should be live. Apologies for the 1 minute delay. There we go. We're live. Hi, everybody. Oh, man. What a great day. This is I've been outside all day. I came in for this. And then I'm just going to go back outside and hang out some more. So what happened today? We have mallard ducks that have set up shop in our duck pond, and we're hoping that that they're making baby ducks, because that would be the best. And they appear to be exhibiting all of the behaviors of a coupled pair of ducks that are in the process of hatching a collection of babies. We had 2 turkey vultures set up in our tree, right outside our house, and then one of them just sort of lifted out its wings to the full wingspan, I guess, just to dry out. And and then it broke the branch that it was on, and so it sort of fell for a second and then had to go and find another place. And man, a turkey vulture, you look at a turkey vulture up close, when they're this close, you can see through binoculars. It looks like someone just took all the feathers off of a bird's head, and it's just raw flesh. They're gross. People always say wow, you look burnt, you look red. I don't know what to tell you. I've been out, I've definitely been out in the sun. I'm wearing plenty of sunblock. But I just, come May, I become red. And that is just, we talked about this last week. We'll talk about it again this week. You'll keep noticing, wow, Fraser looks really red. It's just what happens to me. I tan and I turn red. It's just my life. Tagging is borked tonight. I wear a hat. I wear sunglasses. So take home. It's grosser if you know why. It's so they can eat carrion better. There you go. Yeah, you see a turkey vulture and it flies past. And it's oh, look at this majestic. Is that like a hawk? And then he gets up close and lands on the ground, and then it's just its nasty head comes out. And then the other thing that I do is, have you played with the Merlin app that lets you find birds? So my wife and I are in this kind of bird identification arms race and competition. It's like our video game. And so I go and put my bird app outside and leave it running for an hour. And then I come pick it up oh, I've identified 30 birds. And in fact, I've ordered a new microphone that I can plug onto my phone so that I can do really good interviews with people. And definitely not a way to have a more sensitive microphone to be able to record bird sounds around me and win the battle. So, all right, let's get on with this week's episode. So this is a question show. Your questions, my answers. You know the drill. As always, put your questions into the chat. And Nancy is saying that the tagging isn't working. So that might be a problem. Let's see. Okay, so if you tag a question, Nancy, it's just not working. So we may have to do this the other way. What do we do? Chad might be asleep. Chad's in Europe right now. So, can I tag? Not working for any of us. Uh-oh. Yeah, I don't see it either. But so do you have, is the plugin turned green? Yeah, no, it's a different tagging. It's the tagging that we use for getting the comments into our database. Okay. Plan B. And then we'll just rebuild it. So I believe I can ask me questions. So we're going to have to, so Chad and I are going to have to figure this out. Okay. So I just put in a ask me questions. And so Eluhu testing. This is a test of asking a question. Okay, all right. So this works. So we'll go with this way. Yes, everybody. Yes, I can see these questions. So I'm going to I will copy paste these into a text file, and then we will reassemble this thing the hard way afterwards. Oh, it sucks. I'm so reliant on technology. Okay. So let me open up a text file. Good old Notepad. And then Chad's going to have to search in the database. Okay, so if I do this. Yes. Okay, all right. So this is tonight. So I guess Nancy, Zapfan, John, you're off the hook. So go ahead and use the Q&A system to ask any questions. So just I'm seeing questions from Tony, Kona, Celia Rigby O'Neill, Zapfan, but then I don't know the number of times that I've answered questions. Oh, this is the worst. I hate this. Okay, all right. Okay. All right, so for those of you wondering what it is you stumbled into, this is going to be our question and answer show. Your questions, my answers. Now, normally I tell you that I put emphasis on the people who've never had questions answered before. I have no idea. My technology is gone from me. I got nothing. So, go ahead. Like, it's open season on Fraser. But if I don't know the answer, I will avoid it. If the question is going to be like require too much math and too much work and too much research, I will skip that as well. So, damn it. Okay, I'm a professional. We roll with the punches. The show must go on. Is anything else working? Wonder if we made things and broke things? Because I can use the plugin to take questions from the YouTube comments. No, YouTube must have just changed something about it and didn't appreciate our scraping. Okay. Technology. Okay. All right. Benjamin Dover, do you support the initiative to rename Uranus? I see your name, Ben. All right. All right, so what do I do here? I press record. Press record over there. I start the show. Welcome to the question show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, just write it down and I will gather them up and answer them here. Now, we record this show live every Monday at 5 p.m. Pacific time. So if you want to have your question answered live, like as soon as you think of it, I will answer it, as well as have follow-on conversations and conversations with the rest of the audience. You should definitely come and join the show. We do this every Monday at 5 p.m. Pacific time. Now, before we get into this week's question show, I want to bring you back to the book club. And this, of course, was a way for you to recommend books to me, and I will read them, and then I will tell you what I thought. And so I was able to go all the way through the Revelation Space series. I read Project Hail Mary. There's a bunch of other books that I read. And so the most recent book that had been recommended to me as part of the book club was a book called Accelerando by Charles Strauss. Oh, you have to edit this. All right, hold on. Charles Strauss. Yeah, all right. And so the book that I'm going to review this week was Accelerando, which was... And so the book that I'm going to review this week is Accelerando by Charles Strauss. And this was recommended to me by a bunch of people, both from the sort of space flight, science fiction side, but as well as the artificial intelligence singularity side. And it is the craziest book I think I've ever read. It starts out, and the book is about 10 years old. And so when you're reading the book, it's projecting forward into the future about a decade, which is like now. And so you're reading it, you're going, oh, you missed all these things. The things that you thought were going to happen didn't happen. But then the book jumps every 3, 4, 5 years at a time, sort of playing through the life of a family as they approach the singularity. And it's the first book that I've ever read that really properly understands what exponential growth feels like. And so even though you're 20, 30, 40 years into what's happening, the scale of things are just going off the charts. Like 50, 60 years into this, they've dismantled Mercury, Venus. They have, people are copying themselves into computers. They're sending those computers on missions to other star systems. They are resurrecting dead people. Like it goes on and on and on. And yet there's also a really interesting story that goes along with it. So that's Accelerando, Charles Strauss. I highly recommend it, but you've got to pay attention because it is dense. So the book club, I'm reading books you're recommending. So go ahead. There's going to be a link down in the show notes, but essentially there's a Goodreads group where you're just making book recommendations. I'm picking them based on what sounds interesting to me. I'm reading the book and I'm letting you know what I thought, and then you can follow on as well. So please, I need another book. Let me know what to read next. All right. At Mike Sully 7212. Which way do we look to see where the Voyager spacecraft are heading? Like, I want to point at them. Yeah, the Voyager spacecraft were launched in 1977 and have been traveling in space for like 45 years. And they're definitely running down in their power, but they're not out of power yet. And so they're still sending transmissions home. And like they are in space and they are in constellations. And so NASA has to turn these gigantic dishes in the sky towards the location of where the Voyagers are if they want to be able to send and receive signals from them. So Voyager 1 is currently in the constellation of Ophiuchus, and it's moving towards the Little Dipper. And so like 50,000 years from now, the closest star that it will come to is located in the Little Dipper. So if you know where Ophiuchus is, you can point that at So if you know where Ophiuchus is, you can point your telescope and you can look up the exact right ascension, declination, location for the Voyager spacecraft. You won't see anything, of course, because they're so far away. Even the most powerful telescopes on Earth couldn't see them. But if you had a really big radio dish, you could receive their transmissions. Voyager 2 is in the constellation of Pavo. And same thing. You can point your telescope and you can actually see where the spacecraft are. But yeah, they are out there in space in constellations that you might already know. You might have noticed the planet name that's popped up over my shoulder, and that's a way for you to vote to tell us which of the questions you thought was the best. And last week, the winner was Tatooine. I guess the kind of snarky comment about how I can describe scientific discoveries with a straight face. And so, congratulations, Stephanie McGuire. You asked the best question, or maybe I gave the best answer. Whatever, we work as a great team. So, thank you for everyone who voted last week. And remember, if you want to help me know what questions you like, what you want to see more, clearly you want me to give an enthusiastic response about the scientific method for snarky trolling questions. So, I guess that's just all the show will be from here on out. Anyway, go ahead. You'll see the planet names above my shoulder. At the end of the show, vote for the one you like the best. Just write the name of the planet in the comments down below, as well as part of your question or whatever, and we will tally them up and we will celebrate that here next week. Herner Weisenberg 7052. Are there roughly parabolic-shaped craters on the moon that could be turned into giant radar dishes with minimal effort by coating them with radar-reflective material? One of the cool things about the craters on the moon is that they are almost all roughly circular and parabolic-shaped. And it seems weird, doesn't it, that you would assume that the rocks that are crashing into the moon are coming at all of these different angles, and yet the craters all look like nice circles that are scooped out in this very similar way. And what happens is that whenever any object strikes the moon or the Earth or whatever, it's going so fast, like it's going, in many cases, kilometers a second, tens of kilometers a second. They can be going very fast. And when they strike their target, then all of the kinetic energy is instantly pushed into or released onto the planet that they hit. And so even though an object can be coming in at a very steep angle, as soon as it really smashes into the moon, all that kinetic energy is released straight into the moon and creates this giant crater. And they look quite circular. And you're exactly right that they would be the perfect place for a telescope. The problem is that they're not smooth enough. They're very smooth, but it's not quite what you need. You would need to sort of get in there and polish up these craters on the moon to actually turn them into a proper telescope. But there's been some great ideas. And in fact, I did an interview here on the channel that what you do instead is you set up pylons on sort of around a crater of whatever size that you want. And then you extend a net down from those pylons so that it is hanging down into the crater and it's going to be following this parabolic shape thanks to the lunar gravity. And then that great big radar dish can be a monster radio telescope that could be, say, a kilometer across. Beyond a certain kind of technology, like, you could make other kinds of telescopes, but then the tolerances are going to get harder to get it to. So like radio is very forgiving. And so the wavelengths are very long. It's okay if you have a not perfect telescope. But once you get down to infrared, visible light, then you do need to have something that's a little more carefully machined. But I do really like this idea that you use these craters on the moon as natural sort of telescope lenses for building your telescopes. Vernon Goins. There is no such thing as artificial gravity. The only way to mimic gravity is by constant acceleration in space. Please give up on the big wheel in space. It won't work. So according to Einstein, if you're in a box, if you're in a room and you're sitting on a chair and that chair is, or the box, and that box is down on the surface of the earth, or that box is in a rocket that is constantly accelerating at 1g of gravity, or that box is on the sort of inside wall of a gigantic space station, say thousands of kilometers across, that is rotating, you wouldn't be able to tell the difference on which one you are. They would all feel equivalent to you. That is general relativity. Now, the only way to mimic, now, according to your question or your comment, the only way to mimic gravity is by a constant acceleration in space. Obviously, that would be the best, right? You take some rocket that gives you 1g of acceleration and you fire it for days, weeks, months, years, and everybody on board your spacecraft has 1g of gravity. They just go about their business. They walk up and down stairs. They can have baths. They don't suffer muscle loss, bone loss, vision problems, fluid redistribution. Everything is the best. That just sounds wonderful. The problem is that we have no way to produce 1g of constant acceleration. Our rockets, our chemical rockets, can produce 1g of acceleration for minutes at the most. We don't have ion drives that can produce constant acceleration for any length of time. We don't have the technology. Even nuclear rockets wouldn't be able to provide 1g of acceleration for long periods of time. We don't know how to make fusion drives, and maybe even those wouldn't be able to provide you with the 1g of acceleration that you need for long periods of time. And what if you want to just stay in one spot? What if you just want to be in orbit around a planet and you don't want to hop on your sci-fi drive expanse spaceship and fly off? Like, are you just going to fly off to the far side of the solar system and then fly back and forth to give everybody 1g in their space station? Like, no. So you're going to need some kind of artificial gravity in space, and the way that we know is going to work is a giant rotating wheel. Now, obviously, the engineering challenges of building a giant rotating wheel are ludicrous. Like, we have trouble launching more than a few tons into orbit at a time. And when you think about some of the O'Neill cylinders, some of the really like giant mega projects, like you're looking at thousands of tons, millions of tons. And so in the short term, it's going to be really tough for us to be able to do that. The most practical form of artificial gravity that we're probably going to be using in the next couple of decades is the variety that tries to mitigate some of the health problems that astronauts will experience when they're in space. So you're not going to have this beautiful, giant, rotating space station where everybody is sitting around and you look up and you can see the top of the space station and there's everybody's homes directly above you and you're stuck to the outside of the station. It's going to be that you're living in a space station like the International Space Station. You're in weightlessness most of the time. And then there's a centrifuge that you go and maybe you sleep in the centrifuge, or maybe you put in a couple of hours in the centrifuge every day. And all it's trying to do is help minimize the amount of damage that your body is taking because you are in space. So, I don't know. It's like saying like obviously, going on ships is a bad way to get from continent to continent. What we need are stargates. Teleportation is the way to go. Like, we don't have the technology. And so until we have the technology to provide constant 1G acceleration, we're going to have to use the stuff that we know how to use. And then we'll wait. And then if someone provides a 1G accelerating drive, then everything changes. And being able to use that for artificial gravity is like the least of the benefits of having access to a 1G constant accelerating space drive. All right, those are all the prepared questions. So now we're going to jump into your questions. And again, I apologize. All right. So are you still able to see? How do I see the chat? So there's the live chat. So I can't see. Yeah, Archer, sorry. Are we talking about the Epstein driving it? Yeah, exactly, right? Like, all you have to do is have a science fiction spacecraft drive. Okay, so I am only going to be answering questions from the QA system. So just keep that in mind, that if I don't answer your question, it's because I didn't see it in the QA. I'm not looking in the regular chat. So if you're like, why isn't Fraser answering my question? It's because I don't see it. But, when we get to overtime, then I'll go back to the regular chat. Sam Powell, I know I ask this every live show, but have you checked out the Terrascope concept by David Kipping? Yeah, absolutely. I've even talked to David Kipping about it. So, but like Dr. David Kipping, head of the Cool Worlds Lab at Columbia University, PhD researcher in astronomy, specializing in exomoons, with many PhD candidates under his wing, who writes technical papers for legitimate science journals and also communicates the results here on YouTube. And then there's me, a journalist. So definitely I have no notes for David Kipping. So does that mean that I answered it? No, they don't. Okay, all right. Okay, so let's see the new system. Bakhtir Jawuk. Is stopping at the gravitational focal point for gravitational lensing a problem at high speeds required to get a telescope that far? How do they decelerate, or does it not matter? Why isn't that copy pasting? Okay, all right. So you're talking about the solar gravitational lens, which is one of my favorite ideas, and I've had a chance to interview Dr. Slava Turishev about the solar gravitational lens. I just did another interview with Slava Turishev about the method of propulsion that he thinks will be able to get out to the solar gravitational lens, as well as go to other really interesting places in the outer solar system. So if you haven't checked out that interview, this is me telling you to check it out. Like, just look at the comments on that interview and how excited people are about what we talked about in the interview. I highly recommend it. He's, definitely got some pretty big ideas, and we get into the weeds on that. So the idea of the solar gravitational lens, this is that at about 650 astronomical units away from the sun, the gravity of the sun acts as a natural telescope lens. And so if you put a telescope at that focal point, you can then magnify the power of your telescope by many orders of magnitude. And for example, it could give us an image of an extrasolar planet at a 1 megapixel resolution. So you could see another Earth at 1 megapixel resolution as opposed to a single pixel, which would be wonderful. And so the question you're asking is, like, once you get out to the solar gravitational lens, you're going to keep going, right? If you had to go tens of astronomical units every year, you're going very fast. And so then once you pass that 650 astronomical units, you just keep going. How do you stay in the focal point? Well, the cool thing about this is that you can remain in the focal point. That once you cross that 650-ish astronomical unit range, then it's this cone of focus. And as long as you stay in that cone for the entire time, you can continue to make observations using the sun. In fact, it gets better and better over time because the sun gets smaller, stops being such a big glare in the focal image that you're producing. And so you don't have to worry. You don't have to stop. You just turn back and you just keep drifting for tens, hundreds of years, and you can keep using the gravitational lens as long as you want. I don't know if you saw was it in a question show? Someone asked me about James Webb, and they were saying like, how do we know what things that Webb is looking at? And I mentioned that on the week that I was checking, they were doing observations of Fomalhaut, which is this really cool sort of Eye of Sauron image from the Hubble Space Telescope, and they released the images today, and so we got a follow-on information about it. They were looking for an asteroid belt, and they found an asteroid belt and more. So it's really exciting. So that's sort of like closing the loop on that. Elihu. I'm going to go to Puerto Rico in a couple of weeks. What's a good place to go sky watching? Arecibo's closed. I don't know if Arecibo is a good place to go sky watching. Like, you want to go somewhere that is far away from the city lights. That's the best place to go sky watching. Ideally, you want a place that has a nice clear view to the west, because Venus is still up. So I would try to go to the western side of the island, but it really just depends where you are. Just get away from city lights, and any place is as good as any other. Rolls, I want to buy your guide to viewing the cosmos, but I am from North Europe, or is it more meant for Americans? No, it's for anybody on Earth. And we even have information about people in the Southern Hemisphere, so definitely check that out. Series Kaylee, any doubts about cosmic inflation? Just a journalist series. You didn't know that was gonna be my answer. All right, we'll do this one here. Arg Scott, is there a benefit to making larger helicopters for future Mars missions? So at the time that we're recording this, NASA's Mars Ingenuity helicopter has flown over 51 times. Like, they were expecting just to get 5 flights out of the helicopter, and now they're up to 51. And it's been so successful. Like, imagine like what life was like for videographers before they got drones, right? They had to like shoot images from street level, and now they can have these great sweeping shots as they're on their skateboards around New York City. It's game changer. And so it's kind of the same on Mars. You've got this helicopter that's flying around and is able to observe the route that the rover is taking from above. And geologists just have a field day when they can do this, because then they can see the larger structures, things they want to go and examine. And this was just a test. Like, does a helicopter work on Mars? And the answer is yes. And so the next big question that scientists are going to need to ask is, how much science, how much geology, how much exploration can a helicopter do on Mars? And my guess is a lot. That any and every future mission that's going to go to Mars is going to come with a helicopter sidekick of varying sizes. In fact, right now they're planning to send a helicopter with the Mars sample return mission. It's even going to have like a little grabber, so it'll fly out to some of the, or if there's any problem with the main samples that are on board Perseverance right now, like when it delivers the samples to the Mars sample return mission, then they can go and fly out and pick up the backup samples. These are the ones that Perseverance set down on the surface of Mars. And the helicopter will have a little grabber arm. So it'll fly out along the route that Perseverance took. It'll pick up samples, bring them back to the Mars sample return mission, and then be able to return those back to Earth. And it's, I don't know, there's something just so amazing. Like, it feels like it was impossible. And now suddenly you've got this entirely different axis of flight, right? You had X, Y, and now you've got Z, and it's great. And in fact, it's been so successful, the Chinese are planning to put a helicopter in one of their upcoming rover missions. And I think it would be unthinkable to not add a helicopter to every single mission that ever goes to Mars. And you can imagine when the astronauts go to Mars, they're going to bring helicopters with them. They're going to deploy them all around for all kinds of purposes. Where to go explore the next day, as scouts, as helping figure out some of the dangers that they face. Now, the question you're asking is there any benefit to making them larger? And the answer is, I don't think we really know what are the limits. I mean, the rotor on the helicopter is turning very quickly, and it's got this sort of perfect balance between the size of the rotors, the mass of the helicopter, and the amount of power that it's able to bring in from the sun. And if you make a much bigger helicopter, you're going to have to play with those variables. And so the thing's going to be heavier. Maybe the rotors won't be able to spin as quickly. And you might find that, in fact, like you're constrained in engineering. So, but the one thing I can guarantee is that we will see every possible variation of helicopters in future missions. Kudro and friends, why can't Falcon Heavy rockets go to Mars? Falcon Heavy can send a small payload to Mars. I mean, if like when you think about the rockets that go to Mars or the missions that go to Mars right now, they're on things that are less powerful than Falcon Heavies. Are you wondering like why can't they take people to Mars? Roger Flores, of all the races in Mass Effect, which did you find the most interesting, scientifically plausible? Uh, Man, so like scientifically plausible, I don't really have an opinion about that, but like interesting, like there's a really interesting dynamic between, and I apologize, I forget the the sort of science guys and the Krogans, and how the Krogans were like rapidly breeding, and so they released this phage virus that stopped the Krogans from breeding and stopped these kinds of like the dynamics of the different species in this game are really well thought out. If you haven't played the Mass Effect game, it's terrific. I really enjoyed it. I mean, the problem that you always have with any game is that the aliens are people with prosthetics, right? With little ridges on their nose. And it's really hard. I mean, there are definitely some aliens in them. I forget the name. The ones that look like little moles that breathe. And then there's the ones that look like kind of elephants. There's ones that look like sort of floating gas bags. But yeah, it's a great game series. All right, that's a good one. Rage Quit Quick. What are your thoughts on smart telescopes like Unistellar and Vespera? So I've had a chance to play with one of the smart telescopes, the Vaonis, the Stellina, and it's amazing. Like you take this, it looks like a turret out of a Portal game, and you put this thing on the ground and you sync it with your phone, and then you tell it to start, and it figures out where it is because it has a GPS on board, and then it plate solves a couple of images of the sky and then figures out like where it's pointing. It knows what time it is, and then you then just tell it things you want it to look at. And so you say, well, I'd like to look at this constellation, I'd like to look at that nebula, this galaxy, and then it just goes and finds them and images them. And anybody who's ever owned a telescope knows how difficult it is to polar align the telescope, to be able to sort of show your friends interesting objects in the telescope with very little setup time. Like it is a pain to make a telescope with its go-to setting, like go from object to object. Like once you've got it set up, once it's polar aligned, then yeah, you can go like, let's look at M33, let's look at M31, no problem. But you can spend 3 hours going just a second while you're trying to get your telescope set up, and it is embarrassing. So when you use these telescopes, like, and I haven't used the unistellar one, but we've done reviews on Universe Today. It's amazing, and it absolutely feels like the future. Like you are using this telescope, you're not having to think about it. It's just pointing it at whatever objects you want to be able to see that are available in the night sky. So the downsides of them are that you're kind of locked into the gear. So it comes with the size of the telescope that it has. It comes with the kind of camera that it has, the hardware that goes along with it. And, we've seen technology increase in leaps and bounds. And so I personally prefer to be able to have all these parts be separate. And so you can swap out the mount with a new mount. You can swap out the telescope lenses or the camera or the controller or whatever as the new technology moves along. They're also very expensive. I mean, you were looking at thousands of dollars. And if you were to go and set up your own astrophotography rig for the same price, you could get a more powerful telescope that is more customizable, that's more modular, but not easier to use. And it really feels like right now there is this gigantic gap in the marketplace that all telescopes should be as easy to use as the ones from Unistellar and Vaonis. Like, it's embarrassing how difficult it is to use a telescope that isn't one of those two. And so, they always say like the best camera is the one that you've got with you, right? And so like the best telescope is the one that you're going to use. And so if you do invest in one of those telescopes, you're going to use it. But you will also run up against its limitations. And so you will, if you use it a lot, you'll realize that the pictures aren't as good as the pictures that you could be taking with a more custom built piece of kit. And so you may then end up wanting to sell the thing and put together your own custom hardware. But like whatever gets you into the field, whatever gets you into the hobby. And so if you're the kind of person who wants to be able to just like see nebulae, see galaxies, see clusters, see the planets, the moon, and not think too much about it, and you're not trying to take like astrophotos that you're going to sell or try and submit to Astrophoto of the Day, they're pretty great. Moonwalker. When the ISS is finally decommissioned, how will they do it? Will they dismantle it and let each individual module fall, or fall all at once? Or are they worried about something might survive reentry? Right, so the plan right now is that the International Space Station will be deorbited at some point in the late 2020s. Although, we've heard predictions for when they're going to finally deorbit it, and people keep showing up to extend the lifespan of the space station. So at one point, the Russians said they were going to pull out of the station. The Americans have said that they're not going to maintain it beyond a certain point. And then a couple of years later, they've extended it. And so where we are right now is that it will probably be deorbited at the end of the 2020s. I wouldn't be surprised if it stretches into the 2030s. But like at this point, it is a machine and it is running down and it's getting more and more expensive to maintain it. And NASA has budget that it needs to spend on things like the Lunar Gateway, the Artemis missions, other explorations. So it is definitely going to have a hard time limit in the end. And the plan right now is that they're going to deorbit it using sort of three things. There's thrusters on board the station itself, so they're going to be able to fire those thrusters. There are the spacecraft that are attached to it, and they're going to be able to fire those. And that's probably not enough to give it the kind of control that they want. And so the plan is probably to launch some kind of tug. Now maybe it'll be like a beefed up upper stage from that they might use for some other mission, and they'll dock that onto the space station, and that will assist to deorbit it exactly where they want it to go. Where they want it to go is they want the whole thing to crash into the middle of the Pacific Ocean, a place called the Galactic Graveyard, where they crash most spacecraft when they still maintain control of them. That's where Mir went. That's what many other spacecraft have gone. It's like the farthest point away from any other human being. It's the place that you can crash your spacecraft and do a minimum amount of damage to anybody. And so it'll all just come down together in one big deorbit maneuver, with the station firing its thrusters, with the attached spacecraft firing the thrusters, and this tug to help out as well. Dev Gaekwad, is it possible to make artificial gravity by not using the wheel design like in Stowaway? Yeah, so if you watch the movie Stowaway, they have this spacecraft that flies into space and then it extends out these modules and then it starts to tumble end over end. And you get artificial gravity on the two ends of the station. I think they had a counterweight and then they have their actual habitation module. And yeah, in theory, that method will work quite well. You do get artificial gravity in your module. You probably don't want to go to one full Earth gravity. You probably want to have it spinning so that it's only going, say, giving you Mars gravity or maybe even moon gravity, like enough so that when you pour liquids, they stay in their bowls, things like that. What I like about that methodology is that you don't need to have the rest of the wheel. Like you just are spinning this thing end over end over end. You have to be careful about how you structure it because there are various forces. There's ways that objects that are rotating in space want to orient themselves. And there's a really great video, and hopefully Chad will be able to find it, where an astronaut on board the International Space Station is spinning this handle. And the handle is sort of spinning, and then suddenly it flips over in the other way, and it spins, then it flips over the other way. And so there are sort of axes of rotation that you have to keep in mind. People always worry, like, what happens if the tethers break? But actually, it's not that big of a problem. Like, you are, like, the velocity that you're going towards Mars or wherever your destination is, that's the big velocity. And even if your tether snaps, it's only a slight change between the velocity of the one part of it and the other part of it. And it's probably within your capability, if you have additional fuel on board, to be able to correct and be able to have both parts arrive at the destination as planned. So, I wouldn't be surprised if when we have long-term space flight, like a mission to Mars, some version of that sort of rotating masses will be supplied to provide gravity to the crew. Sunny Knox, any news on the juice antenna that wasn't unfolding? I don't think so. I think it's still happening. What time is it? Okay. Whoa. 6 o'clock. All right. Can we convert photosynthesis produced by plants into electricity down here on Earth? I have no idea. Okay. Waleed Damouni, isn't it easier to do robotic tests on Mars rather than have another mission to bring samples and all that complexity? No, I don't think so. You can definitely do very simple exploration on Mars. Like, you can take a picture of a rock, you can try to understand the chemistry of the rock, you can drill into a rock to sort of reveal a little bit what's underneath. There are various instruments that you can deploy. But when you think about the kinds of labs that we have here on Earth, I mean, a geologist can go into this lab and they've got access to kilns and lasers and mass spectrometers and tools to measure the gas composition. They've got microscopes, electron scanning microscopes. Like, the list of tools they have at their disposal just goes on and on and on, as well as the ability to bring new experiments into play when you think of them and as they get invented. Like, one thing that's really kind of interesting is that when the Apollo samples were brought back from the moon, they put a bunch of them away in a really secure storage, knowing that the devices to run experiments on would improve over time. And so that when you had this next round of equipment that they could do their tests with, they could bring the samples out of cold storage. They wouldn't have interacted with the Earth's atmosphere at all, and they could do these experiments. And this is ongoing. And so a lot of the times we see new experiments being run on samples from the moon. And so the same thing will happen with Mars, that you'll have these samples brought back from Mars in pristine condition. They'll be put into this place where they won't be influenced by life on Earth, there won't be any contamination of Earth into the samples. And then they'll bring out little bits of the samples and share them among researchers. And then over the coming decades, be able to perform new experiments. And there's just no way that you could replicate at the same level of sensitivity that you can with the Mars Sample Return Mission. Like, if there is life in these samples, or if there is fossilized life, or is there any evidence of life, you really do need a lab on Earth to gather the evidence. And like, what you don't want is, you don't want your results to be inconclusive. Like, when you think about how people still argue over what was found by the Viking landers, it's because, for all of its ability, Viking was a mediocre scientific laboratory compared to what you have on Earth. And so it maybe found evidence of life on Mars, and maybe it didn't. And Mars researchers might still get into heated arguments about what it found and didn't find. And like, that's not helping, right? Like, did you find life on Mars? Maybe, right? No, let's get a really solid answer. And that's why we want to have the samples brought back to Earth, where the best scientists on Earth and the best equipment can try to get to the bottom of this question. Rocky Giuliani, I was wondering if it would be possible to locate the theoretical black hole in this solar system using gravitational waves. So the black hole idea, a primordial black hole, was only introduced because astronomers haven't been able to find Planet 9 yet. And so whatever object Planet 9 is, it's going to be producing the exact amount of gravitational waves as a black hole would be producing, of the same mass, that has the same effect on the solar system. So it would be indistinguishable between a black hole and a planet with the same amount of mass. But that said, neither of them are detectable with our ability to detect gravitational waves, like by orders of magnitude. Like, the only kinds of gravitational waves that astronomers can detect right now is when black holes with tens of times the mass of the sun are crashing into each other at speeds close to the speed of light. Not done. Who decides what person or persons can mentally sit in a tin can for 2 years to get to Mars and be there when there's no blue sky or green trees or anything but rocks and dust? I mean, there are people at NASA and the European Space Agency and the Chinese Space Agency who are choosing their astronauts. And the kind of psychology that they're going to be looking for, the kind of people to be able to handle that length of a mission, they're going to be looking for very special people who have demonstrated that they can handle stressful situations very well, that they are experienced with some level of being alone or in a very small group working with other people, maybe people who are part of a submarine crew or have been on some of these missions before. But a lot of the times, like when you fly to the International Space Station or when you go to the moon on the Artemis mission, you will be experiencing challenges, and it's those kinds of stressful situations that will bring out the best in people, or the worst. And so all of the people who are involved in NASA right now, in the European Space Agency, Chinese Space Agency, Russian Space Agency, right, they are going to be under scrutiny from the people saying, like, does this person have the right capability? That also said, I mean, there is a lot of work that's being done in the psychology of astronauts. I actually did an interview with a researcher who has been looking into this and trying to sort of make predictions about what it's going to take to be able to help astronauts deal with the homesickness, the loneliness, the stresses of being far away from Earth, away from easy assistance. It's going to be hard, but we've had human beings who've set out on sea voyages. There are people who travel around the world, who solo sail around the world, who serve in submarines. There was a woman who just spent more than a year in a cave by herself. She came out fine. So, like, can human beings handle the solitude and stresses of a mission to Mars? Is definitely something you want to keep an eye on, but I think it is a problem that is relatively straightforward for us to solve compared to the lack of gravity, the constant cosmic radiation, and then all of the things that can go wrong on a multi-year mission to Mars when you're too far away from help. All right. Wow, I got through most of the questions because we're using the QA system. So I'm going to turn off I wonder if it will give me a report. Okay. I'm going to end the Q&A, but I really hope that doesn't end the live stream. It wouldn't end the live stream, right? Okay, so I'm about to press a button. When I press that button, if the stream ends, goodbye. Otherwise, we're going to go back to the overtime. All right, let's see what happens. This will remove all questions in the question list. Confirm. Okay. And now we're back to the regular chat. Okay. All right. So I'm going to record all of my post-production stuff, and then we will get into overtime. So don't leave. The show will continue. All right, good. If you like my answers to your questions, as well as the other things that we do at Universe Today, consider joining our Patreon club. This allows us to keep minimum ads for everyone. Like, as you can see, there are no ads during this video. As a patron, you'll also get an ad-free experience on universetoday.com for life, even if you unsubscribe. You'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who's already subscribed, and welcome to the recent newcomers: Joseph Conrath, Patrick Gingst, Richard Hensley, Tim, Scotty Mack, Mary M. Leal, Ty Gardner, Don Byrne, Bruce Berry, and Joseph Gentile. Join the club at patreon.com/universetoday. All right, those are all the questions that we had this week. Thank you, everyone, for asking questions in the YouTube comments, as well as showing up live during the show. Remember, we do this show live every Monday at 5 p.m. Pacific time. And don't forget to vote to celebrate whichever question you thought was the best. We'll see you next week. And the outro. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word. There are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast, or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent and keeps ads at a bare minimum. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Paul Davis, Vlad Shipolin, Jay Dennis, David Giltonen, Maud So, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verabioff, Andrew Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. And then I got to do the intro. Where should we look to see the Voyager spacecraft? Could we turn craters on the moon into Where should we look to see the Voyager spacecraft? Could we turn craters on the moon into giant radar dishes? And is the best kind of artificial gravity constant acceleration? All this and more in this week's question show. Okay, and I will stop my recordings. Okay, we landed this madness. Chad. Platform platitudes. He must not be starving. He's reading this stuff at a casual pace. I am starving. Oh my God. Didn't eat dinner. Hungry. What's the camera and the lens you use? I'm using a Sony A7C with a Sigma. No, it's a Tamron 28 to 75 f2.8. I could eat a platypus. Yeah, the interview about printing a bunch of aluminum antennas on the surface of the far side of the moon was fun. Connor Arroyo, could you elaborate on the potential Earth contamination of other planetoids, moons, asteroids, planets by Earth-borne tardigrades that hitch a ride? So, well, like one of the issues, like the Beresheet lander, when it crashed onto the moon, it had tardigrades on board. And so people are a little bit concerned that tardigrades probably survived that impact on the moon. And so right now, there are probably tardigrades on the moon. But the moon has no oxygen. The moon has no water. Well, the moon has oxygen, but it's in the rocks. The moon has no breathable oxygen, no liquid water. And so the tardigrades are going to be in hibernation until the radiation kills them. And so, yeah, I mean, if we infected various objects in the solar system with tardigrades, it'd be the same situation, which is that it's not habitable places. But over long periods of time, you can imagine one of these tardigrade-strewn space rocks crashes into Europa or Enceladus, or now apparently the moons of Uranus, and you would get the potential for life to infect one of these places. But it's they're on the clock because the radiation from space is going to try to kill them at the same time that they are hibernating on this spaceship. The moon has been colonized by angry tardigrades. Yeah. All right. God, this sucks. I hate not having my technology. It's dumb. Nancy, don't rush you. I can't read your chat, Nancy. I can only see the questions. So if you could make your reminder in the form of a question, that might be the way to go. Ed DeBoer, given enough time, will there ever be a JWST deep field image that is so filled with galaxies it is more white than black? No. Like JWST still has its fundamental limits. Like you're seeing the best pictures from JWST, its versions of the deep field. And no matter how big and how many galaxies there are, space is still vastly bigger. The gaps between these galaxies is so much more, so much bigger. And then you're going to reach the limits of what JWST can actually see. So no. Platitudes. Kim Barron, mirrors reflect visible light. Do they reflect other wavelengths? What a great question. Um, so mirrors will reflect infrared, and mirrors will reflect ultraviolet radiation. And so the Hubble Space Telescope is a perfect example of that. Like it has this mirror, it's a 2.6 meter mirror, and it's able to see into the near infrared, it's able to see into the visible light, and it's able to see into the near ultraviolet. But when you look at, say, JWST, it also has mirrors, and it's seeing into the mid infrared and the far, well, not the far infrared. Spitzer could see into the far infrared, but it's seeing into the mid infrared, and the Spitzer Space Telescope would see into the far infrared. And then think about radio dishes, like for the microwave telescopes, like at ALMA, and then like the radio dishes of the Very Large Array, Arecibo. Like, is that a mirror? Right? Like if like you're not going to get a reflection from it in the way that you would, like if it was just like a glass mirror, you wouldn't get it focusing radio transmissions. You need a different kind of structure. But on the small end of the spectrum, literally, when you go up to the X-rays and gamma rays, no, mirrors don't work anymore, and you need a different method. So with X-rays and gamma rays, what they do is, instead of having a mirror, they have this almost like a cone. And as X-rays come into the opening on the telescope, they glance against the most of the X-rays will pass right through the spacecraft, but the ones that get close enough to its optical system will glance off and kind of bounce down, sort of like ricochet down into the detector at the back of the spacecraft. And so they're able to just slightly capture these X-rays that are passing the spacecraft. So it's a completely different technology, what's required to be able to see X-rays and gamma rays. Paul Michael Freeman. Hey, Fraser. Greetings from a reader viewer of over 20 years. I remember you having hair. I remember me having hair. Yeah. For those of you who don't know, I'm now into my 25th year of running Universe Today, being a space journalist. And I'm still having fun. I'm still having as much fun today as I did when I started. Yeah, X-ray megaphone. That's a good way to describe it. Axions. I wondered about the neutrino images. How do you get an image without focusing the source? So the trick with neutrinos is that you aren't so like think about the ice cube instrument in Antarctica, right? It's this 1 cubic kilometer of ice. And so neutrinos are passing through this block of ice. And most of the time they're not interacting with anything, but occasionally a neutrino will run right into a proton or a neutron or whatever, and it will disintegrate and create this sparkle of debris. But the debris showers in a very specific direction. And so you can, and then that debris is going past rows of detectors. And from that, they can figure out where that neutrino came from. But like an image of a neutrino isn't really a good way to describe it. It's more like you're getting, you're able to, based on the shower of particles that are spraying out in one direction, you're able to locate generally the source of where that neutrino came from, like mostly coming from the sun or from this supernova event. And that's the 1 kilometer version. They're working on a 10 kilometer version that should provide more accuracy. It's time to have an ice cube conversation because I think it's such a great telescope. Shavran Rao, in 25 years, which space mission has been your favorite? I don't have an opinion. I don't have, like, you know me, I don't like superlatives. And there's been so many, like Cassini. Like, do you remember Cassini? Like, we had pictures of Saturn and its moons. and like New Horizons, we got those first pictures of Pluto. Um, JWST has been on my watch, pretty much the entire thing. Like my career has been, welcome to being a space journalist. Here's this idea called the the Next Generation Space Telescope, and then it turned into JWST. Um, who's running Morse code on the right? On the right of my camera? Like in the YouTube thing? Ice Cube seems more friendly than Ice Tea. Thomas Sidicus, why is it important to put telescopes, start rockets from the equator? Gravity is the same on Earth. Why not put a telescope to Antarctica to look in another direction? So a bunch of questions there. So there are telescopes in Antarctica. There's a bunch of telescopes in Antarctica, and it's a terrific place to put telescopes because you've got some of the clear skies on Earth. And there's a place called Dome C, which is like really high altitude, also really cold. You pretty much can't have a better place on Earth. But maintenance is tough when your telescope is in such a hostile environment. But there's a bunch of observatories in Antarctica right now. Why do we launch from the equator? Because you get to take advantage of the rotation of the Earth to get your spacecraft into orbit. And so, the Earth is turning at 1,000 kilometers an hour. And so if you launch from the equator in the direction that the Earth is turning, then you are already moving at 1,000 kilometers per hour that you don't have to then make your rocket fly. As you move farther north, farther south, you get less and less of that rotation. You can sort of imagine, right? Like if you're standing at the North Pole of the Earth, you are turning once every 24 hours and you're going essentially zero, right? But if you're at the equator, you're moving 1,000 kilometers an hour. And so your rocket takes advantage of that. Lurkster. So is the neutrino debris that you measure not the actual neutrinos? Yeah, exactly. Yeah, so you're measuring the debris of the neutrinos, not the neutrino itself. There's like another telescope that works like this that I really love, and it's called Cherenkov radiation. So there are a series of telescopes that measure cosmic rays that are coming from space. And as the cosmic ray, normally you can't measure them because the Earth's atmosphere protects against these cosmic rays. So as these cosmic rays strike the Earth's atmosphere, they hit particles in the atmosphere, and then they create this spray of particles that flies down to the Earth, and astronomers are able to detect with these Cherenkov radiation telescopes. They're able to detect the spray of particles that are coming from these cosmic rays and then use that to kind of reverse engineer what was the particle that hit. But it gets even crazier than that. And this is something that Dr. Pamela Gay, my co-host on Astronomy Cast, has sort of, has nerded out about many times. And which is that the lifetime of those particles, some of those particles, is too short for them to survive the journey from when they're created, when the particle hits the atmosphere, to when they reach the Earth. But because they're going so fast, they experience time dilation. And so from an outside observer, like from them, they only experience the amount of time it takes them to decay. But from an outside observer, they can last so long that they actually reach the detector before they had a chance to decay, because they're moving so close to the speed of light, which is just like, it's an amazing concept that you wouldn't be able to observe those particles without the time dilation. What happened if you launched Starship horizontally underwater? Yikes. Michael Freeman, is there any activity considering a moon-based telescope? I just did an interview about a moon-based telescope. I've done like 3 of them, but check out the interview that we did within the last couple of months anyway about the Farview telescope. What's the time? All right. I'm going to do one more question, then I'm going to run. Church discography. Do you think that by the end of the century, all of our space explorers will be robots? I mean, aren't they already? Like, what space explorers do we have that aren't robots? I mean, yeah, we have some astronauts on board the International Space Station, but they kind of go around and around. Are they exploring space, or are they just doing experiments in space? So, all right. Thank you, everyone, for hanging out today. Thanks to the moderators with the failing technology. We will definitely have to get to the bottom of this, and hopefully we'll have this sorted out by next week. What's coming up? QA tomorrow. Well, the last week's QA will be releasing tomorrow. I've got some more cool interviews. Who am I interviewing? So I'm interviewing a researcher tomorrow about how to remove lunar regolith using liquid nitrogen. So it's awesome. I mentioned it in the interview that I did last week. And then the researcher who worked on the liquid nitrogen concept reached out and he was like, I did that work. Do you want to talk to me too? I'm like, yes, that sounds great. I interviewed Christopher Morrison from, I forget the name of the company. Anyway, his mission is, I did an interview with him about 2 years ago. It's a NIAC grant, and he actually is working on 2 NIAC grants. So one of them is called the Lunar Flashlight, where you have a decaying chunk of some element. I forget what the element is, but essentially it's providing power to the spacecraft. It's keeping the spacecraft warm on the moon, but it also is a particle detector or a particle releaser. And so they call it the lunar flashlight. And so this thing will be sort of keeping itself warm, but also firing out streams of particles at various targets that you can use to analyze their composition. And then the other idea is this idea that I really like, where you take an RTG, like the ones that are on board, say the Voyagers, the Perseverance, whatever. It's producing a ton of heat, produces electricity. You then bolt it into an ion engine. And so you've got the RTG producing the electricity. The ion engine is just giving you acceleration, and that's it. It's like a drag racer, right? And so you could do things like fly out to Oumuamua, collect samples, and return them back to Earth. So we talk about that. So as a form of propulsion. So lots of cool more interviews coming up this week. All right, I'm going to go. But again, thank you, everybody, for hanging out this week. And we will see you all next week. Press the button. There it is.